We will still be using in every proof theorems from last unit. Every proof we do will still have something to do with last unit's theorems. The only difference, you're going to start seeing parallel lines imply in your proofs, just like we did yesterday for our justifications. I'm going to start off this first proof a little differently. You guys see I listed all the statements. I'm going to try to pull the reasons out of you guys. All right, so we have A parallel to B. Quick reminder from yesterday, how do I label a line, two lines that are parallel? What symbols should I be putting on there, Matt? If I want to show two lines are parallel on a diagram, what should I put on there? Arrows, good. So A is parallel to B, and C is parallel to D. If you want to double up on the arrows, that's fine. It's not needed because both of them will be pointing in the same direction, so you know which are parallel. All right, here's my first statement. Why is 3 and 2 supplementary? And why they're not linear pairs, so let's get that out of the way. You need something else. They're definitely not linear pairs. Got to figure out what they are, though. 3 and 2, what type of angles are they? 30 seconds, talk to your group. What type of angles are 3 and 2 from yesterday? Everyone's in agreement. Good job. What type of angles are they from yesterday? 4, Doyle.
Same side interior.
Good job. Same side interior. So this was a pain in the butt yesterday, but it's paying off right now. What am I going to write in the reasons? Same thing you wrote in your justifications yesterday. How did I start it off? Parallel lines imply. Then you tell me, Doyle, what type of angles are they?
Same side interior.
Same side interior angles are, and then you tell me, are they supplementary or congruent? In this case, supplementary. So that's why 3 and 2 are supplementary. All right, I'm also going to say 1 and 2 are supplementary, and I'd like to know why. 1 and 2. 30 seconds in your group. What type of angles are 1 and 2? What type of angles are 1 and 2? 11 here. Oh, that snuck out on me. Gianna, what type of angles are they?
Same side.
Also same side interior. Yep, so I'm going to have the same reason. Okay, now I need to get 1 and 3 congruent. And before I let you go to your group and decide why, first, I want to show you 1 and 3 have no relationship. And when I say no relationship, they're not alternate interior, same side, corresponding. Here's how I know. And here's how you guys can always test to see if angles are related or not. Here's angle 1. What lines contain angle 1? Line A and line C. Here's angle 3. What lines contain angle 3? B and D. Do they have any lines in common? Therefore, there is no relationship. Okay, and that is why this is not a two-step proof. They have no relationship. If they do not share a line, aka a transversal, all right, if two angles do not share a line, that means there's no relation. So somehow, though, I want you and your group here in 30 seconds to look at what you wrote in step 2 and 3. And from last unit, look at your theorem sheet. How can I get 1 and 3 congruent now? Go ahead. I'm not going to say anything. Talk to each other.
Yeah, because they both equal to. Yeah, supplements the same. Yeah, my bad. I think I was.
And what are we thinking about in our groups right now? What are we going to use here? From last unit to have 1 and 3 congruent. Ziv, what do you have? Correct. Notice 3 and 1. Hey. 3 and 1 are both supplementary to the same angle. So I could say supplements of the same angle are congruent. Now, I cringed when automatically most groups said substitution. Let's clean that up. Substitution would work if I knew these were equal to each other. Substitution only works for equal quantities, not supplementary ones. Okay? All good? Questions? Okay, number 2. Now it's starting from scratch now. Alrighty. Everyone look at the angles. We're asked to prove congruent. Make sure you can locate. Don't mark them, obviously, but make sure you can make sure you can locate them. CDF and DEF. Real quick, hey, pencils, pens down here. Pencils, pens down. I want to show you why this is not going to be a 2-step proof so you don't fall in this trap when you're doing them by yourselves. Here is CDF and DFE is right here. Do they have a line in common? Those angles I just highlighted, the prove angles, do they have something in common? Yeah, they have DF, right? So does anybody know what type of angles those are? They have that line in common, that transversal, so they should have some type of relationship. What type of angles are CDF and DFE? What do I call those? Something we talked about yesterday. Nothing, huh? Inside or outside? Inside? Same side or alternate sides? What are they called? Those are alternate interior. And remember, it was a little elementary schoolish, but what letter did I ask you to look for yesterday with alternate interior? Everyone see the Z? Okay, so they're alternate interior, so they should be congruent. Why isn't this 2 steps then? And yeah, they're congruent. They're alternate interior. Anybody know what I'm missing here about those two? FE and CD need to be what for them to be congruent? We went over this at the beginning with Gianna. They got to be parallel. So that's why this is not a 2-step proof. You just can't say, oh, these are congruent because they're alternate interior angles. You need the lines to be, these lines, CD and FE, to be parallel. Okay, so that's why it's not 2 steps. But I did give you parallel lines, though. AD and FB. So write in your group, I'll give you a little more than 30 seconds right now. Using AD and FB being parallel, find a pair of angles that are congruent or supplementary. Now, go ahead, talk it over in your group. Using AD and FB, what angles have to be congruent or supplementary, and why? And be careful before you write the reasons down here. All right, here we go. 12, Olivia, did your group find anything? Because they're what type of angles? Alternate interior. Good. Now, hey, whoa. You guys will notice something about me very quickly. I don't like to just throw a bunch of statements up and hopefully it comes together in one magic, beautiful piece at the end. I like to plan out with you before I write it in. All right. I want to plan out what we're doing before I just start slapping stuff into statements. Where are we going from here? True. Those are congruent. But how do I get the bigger ones congruent now? What am I going to have to do here, Gian? This is an addition proof. All right, this is an addition. So I'm going to turn back into Mr. Carlino from Unit 2. How many quantities do you need to add? 2. I only provided 1 in the givens, and where's the second one coming from now? The alternate interior. Okay, so that's our plan. It's going to become an addition proof, but before I do addition, I need to tell you those alternate interior angles are congruent. Angle ADF congruent to DFB. Remember, I want the reasons we used yesterday, not your own thrown down. Because if you write alternate interior angles are congruent, that's a false statement. They are not congruent unless you know what? Parallel lines. All right, I need those first. So parallel lines imply alternate interior angles congruent. Now add, right? Now I have two equal quantities. What do you want to add together? Name the pairs of angles you're putting together for me. Oh, for Doyle, name a pair that you want to add together. Angle.
CA.
Yep, with.
And ADF.
You got it. And then we'll set that equal to the other pair, which is BFE plus angle DFB. Addition. And my wonderful honor students here, what unit number are we on? 3. And guess what? It's not changing. If I add or subtract right after it, substitute, whether I'm in unit 3 or unit 10. Okay, good work. So are you seeing how these proofs are changing slightly? You're still going to use the unit 2 theorems at the end. It's just in the middle now, new pairs of angles are going to be alternate interior, same side interior, corresponding. Okay, that's the new part of these proofs. All right, one more, and then you're on your own. All right, set her up there. Last one here. We don't do many. There's no reason to do all these proofs together. Okay, here we go. Is there anything in the givens that's catching your eye? Bisects, right? Now, last unit, at the beginning, we said if we see bisects, that automatically has of equal quantities. And then we started to do a couple proofs where it didn't mean it. So how am I going to know if this is definitely has of equal quantities or not? Ready? Answer a few questions. How many angles are you taking half of? How many angles are you taking half of?
2.
2. Angle JEB and angle EGD. Can you please go look on your diagram for me at those 2 angles we're going to take half of? And tell me something about them. Matt, what do you notice?
They're congruent.
Why? Because they are?
Corresponding.
Everyone agree? So the angles we're taking half of are congruent. Wait a second, wait. Halves of equal quantities, right? This is a halves of equal quantities proof. Because what I'm about to take half of are equal. Did we say they were equal yet? What we're about to take half of, JEB and EGD, did we say they're equal? No, so we better put that in right away. Step 2, if you're going to take halves of equal quantities, they better be equal first before you take half of them. So angle JEB congruent to angle EGD. Matt, why?
They're corresponding.
Parallel lines imply corresponding angles congruent. Okay, I'm still not ready to say the halves are equal yet. Anybody remember from unit 2 what I still need to write down? What I'm about to take, the whole angles are equal, but I still need to tell you. What's up, Aiden? Yeah.
Isn't it like the 1/2 of JEB?
Well, you got to show me you're taking half of those now, right? So go ahead. Half of, we'll take JEB. Half of JEB. And now you got to give it a new name, right? So everyone look on your diagram. If you took a half of JEB, I can call that either JEF or FEB. But look at the proof statement. Which one do I want to call it? FEB, right? And you need to tell me you're going to take half of the other angle, EGD. And what should I call that angle? You have two options, EGH or HGD. Which one are we using? HGD, right? The one in the proof statement. What's my reason here? Because it's not halves of equal quantities. What's up, Zoe?
Definition of bisect.
Darn right, that word came up. Definition of bisects. Tells you you're going to cut it in half. All right, you're telling me the whole angles are equal. You're going to take half of them. Now you tell me the halves are equal. Okay, now you set the halves equal. Angle FEB congruent to angle HGD. Halves of equal quantities are equal. All right. You should have, and I know my answer key is up on Classroom. You can go check. I just hope you guys aren't going to just copy it down to get it done. You should have no two-step proofs here. Okay, no two-step proofs. And if you're ever wondering why, call me over. You guys can definitely go separate, work on this with whoever you want, like it's a review for test day. All right, but let's get this done. And there are no two-step proofs tonight. No, those are done. All right, you won't see those ever again.